Lord. All right, so we're going to learn about a gajillion graphs today. At least 9, maybe 10. The majority of these I will not expect you to create on your own. Okay? But you do need to be able to read all of them. And remember that the test over this is not until whatever day I said it was. Right? We have plenty of time. Like, I'm not expecting mastery of it today. None of them in particular are ones that are like, oh my God, this is impossible. But they all, whatever, it's fine. You guys know what I'm saying, right? They're all studyable, but like it's on you to do that studying. Like that's that big difference, right? Okay, so the first thing we're going to do, all the graphs that we're going to learn today are based off of the frequency tables. So we're going to pay attention to those exact same frequency tables that we did yesterday. Okay, so the first type of graph we're going to learn about is called a histogram. And by far, the histogram is the most common statistical graph. Okay? And essentially, a histogram is a graph of the first 2 columns of our frequency table. Everybody good? So let's go ahead and use this one. So we'll make a histogram for the number of credit hours. Okay, so every statistical graph needs to have a communicative label. Like you should be able to tell the context of what's going on from the labels. Okay? And what we're going to do is our left-hand column is going to be the frequency.
Is it always the first 2 columns?
For a histogram, yes. All right. And so basically we're going to make a bar for our first class. And what you're going to do is put the midpoint as the label for that bar. So we have the 10, the 21, the 32, and the 43. Is everybody with me? And then the height of those bars are going to go up to the highest frequency. So what is my highest frequency here? Nope. 9, because that's the total. It's not any one of the bins, okay? So we're going to... something like that. And I'm going to go ahead and just label at least one of them so that I can tell that the scale is 1, 2, 3. All right. And for a histogram, the x-axis needs to represent a frequency of 0. No matter what, it needs to represent a frequency of 0. So you can't like make a jump on a histogram. Anything that's a frequency, the lowest number has to be 0, and then it has to go up by a given scale. Okay? So this first bar, what was the frequency for the bin whose midpoint was 10? 4, so it's going to go up to the 4th tick mark. And then the next one was the 9. And then the 4 again. And then 2. Does it feel okay? The midpoint, the only reason we found the midpoint in the frequency table is to help us kind of get a vibe for this. Does that make sense? Okay. Will you guys give it a shot to try the histogram for the other frequency? Questions? Theoretically, they need to be the same width. I get when you don't have graph paper that can be kind of annoying. Don't stress about that because on the test you will have graph paper available to you. If I ask you to draw a histogram, you can always draw it on a separate sheet of graph paper and turn it in. Okay. Everybody good? Okay. A histogram, and with histograms we actually have two different kinds. Sometimes we use the frequency, and this is just the number of times it happened, and sometimes we use the relative frequency or these graphs. What are some observations we can make about the data or about these groups of people based on these graphs? Let's look at the ages graph. What are some things that we can see by the graph that we couldn't necessarily see by looking at just the table or looking at the bars represent a range, for sure.
I was going to say, like, more students are in the 21 age range.
Yeah, I mean, we could say from here, it's a lot easier than from, say, looking at the raw numbers, that the majority of the students are here with a few older students. Yeah? Is that what, you guys with me now? Okay. All right. And so the basic idea behind the graphs is we can look for those general trends. Current data set.
Oh, it's 16. Wait.
Oh, this isn't the same data set. That's why. Okay. My bad, guys. All right, so that was when we use the relative frequency that y-axis is the percent of the time something happens instead of the frequency. Now you notice a lot of similarities between these different graphs, yeah? Okay, so what are some things you notice as we look at either these graphs? So for example, most students are young. With a few older students. Which isn't that surprising. Is it? Okay. What about when we look at this one? When do we see some things? Okay. How's that? There's something else that kind of jumps out at me there.
The 25.5.
There are some potential outliers. And for right now, we're just going to use the word potential because we haven't talked about how do you determine if something is an outlier or not. We got some time before we get to that. All right, cool. This is a different, my bad. Next, we are going to look at something called a frequency polygon. So as you guys look at, say, this graph, this is a frequency polygon. What does it look like? It looks like a line graph, kind of, right?
Top of the dot.
Yeah, each dot
Or like the top of the top.
each dot is a bar from the histogram, really. And it kind of shows us those same things where we can kind of see, like if I look at this, I see that same gap that was in the other histogram, which makes this feel maybe like an outlier. Maybe. Is this making sense? Okay. All right. This one's called an ogive. Okay. What are you noticing about this one?
It's very linear.
It's starting to, it appears linear. What else?
10 isn't the stuff, like, it's like shifted to the right.
Okay.
The numbers on the bottom.
Yeah.
What is the y?
What is the y-axis? You guys tell me.
Percentage of people. That would. It's people.
Nope. Because the frequency at 16 was an 8. What was the frequency at 16? This was the credit hours graph, guys. So go back to your credit hours table, frequency table.
6.
The frequency was what? At 16? At the midpoint of 16?
10.
Which one?
Or unless, maybe this,
Oh.
okay. I thought these were the same data set because they came from the same source. Okay. Here's what's happening. You guys, do you notice that it is always increasing? Yeah? Okay, because the label that should be here is cumulative frequency. And since cumulative frequency is adding up each time we go, are you guys with me? All right, so are you with me that this dot looks to be, at x equals 16, it looks to be at 8? Okay, so that means 8 people were taking 16 credit hours or less. And if I wanted to, I could draw a histogram from this because this went from 4 to 8, right? So I could draw a histogram that goes up to 4 here and then would stay at 4 because it went up by another 4. And then the next one only went up by 2, so this bar would only be 2. Do you guys see what I'm saying here? Okay, so here's why I passed out the graph paper. I would like you guys to do an ogive and a frequency polygon for the ages frequency table, just so you can get some practice drawing them. Because it seems reasonably likely that drawing them, huh?
This one?
The ages one, whichever one is
the
it.
frequency and
Yes, the frequency polygon and the ogive of the ages one.
the front.
Mm-hmm.
We did it a little bit too. The bottom, right? Just making sure.
When you're done, you want to check your answers. If you use slightly different scales, that's not a big deal. Are we feeling okay? And how do you guys feel like if I gave you one of these graphs, as long as it was properly labeled, that you'd be able to like make conclusions from that graph so far? Perfect. Okay, let's take 5. I think. Oh yeah, 2.4 is next. So the first type of graph I want to talk about is called a stem and leaf plot. I think you guys have seen them before. So basically, for a stem and leaf plot, it's a way of putting the numbers in order, or I keep saying numbers, but I should say observations, because this is data that came from an observation of something. Okay, it's putting them in an order, and showing kind of like some shape with it as well. So what you're going to do is draw a vertical line. And on the left of the vertical line is your stems. On the right is your leaves. Cool? All right. So the stems I'm going to use for this particular data set is I'm going to notice that I have data that's in the zeros or in the 1s through the 40s, yeah? So my stems are going to be 0, 1, 2, 3, 4. And in this particular stem plot, the stems are the tens digit. Does that make sense? Okay. In some stem plots, the stems are the hundreds digit. Some stem plots, the stems are a dollar amount versus a cents amount. Okay? Do you guys see what I'm saying there? So for example, so basically what we can do is we're going to say, all right, how many of these numbers have a 0 in the tens digit? I think it's just this one, right? So I go ahead and put a 5 here. I've done that one. Then we're going to do everything with a 1 in the tens digit, but we're going to do them in order. Okay, so first I'm going to do the 11.
13.
And then after and how many 13s are there? 2. So I'm going to draw that 3 twice.
Wait.
You with me? Because the number of things plotted here needs to equal the number of observations that we have. So if an observation occurs more than once, you list it more than once.
So 6 and 3 sevens? 4 sevens? 16?
There's only 1 16.
4 sevens.
1, 2, 3, 4. And that's it, yeah? Okay, so then we do the 2s.
25.
There's 1, 2, 3 25s. And then 26 and then 2 29s.
Okay.
Is that right?
Yep.
There's how many 29s?
What would make you mad?
If it was this, like, if I'm looking for a graph, it's this.
And you got this?
That would be so hard to see.
Oh, I don't think so, but let me show you something when we're done with it. Because I actually think this is just as easy as a histogram and slightly more useful because of...
Really?
Yeah, but you won't see it now, but you'll see it in a second, okay? I want to finish it first, okay? Then the 30s, we have a 1 7 8.
Oh, okay.
And then Savina said something, but it was a little...
You get 4 out of 5. That's fine.
Okay, and you guys, because the stem plot, the stems could stand for a bunch of different things. Like, this could be $2.50. Do you see what I'm saying? This could be 2,500. We don't know. So we always, when we create a stem plot, create a key. And for that key, you're just going to pick one set of values. I'm going to do the 2 vertical line 5 and say that that's equal to 25.
It's not bad.
Now, Graham says this isn't useful. I'm going to push back ever so slightly, okay, Graham? And yes, this looks challenging to read, but there's something that I like. If we look at it this way, it's practically a histogram when you look at it on its side. Do you see what I'm saying?
Yeah.
And so we can get the same kind of vibe for the different frequencies and how often certain observations occur.
Yeah.
The other thing is from here, I can find a median relatively quickly because it puts it in increasing order. So the reason I like the stem plot a lot is I can see many of the same things as I see in a histogram, as well as it sorts the data for us so that it becomes easier to do some of those relative position type measurements, like the median. Or if I wanted to find the max and the min, I don't have to sort through and see which one's the biggest and which one's the smallest. That 5 doesn't get lost in it. We can see min, max pretty quickly. That's why I like the stem plot a lot. Everybody good?
Yeah.
Okay. Now, there's one more thing I want to show you that I could see being used. And that is writing this stem plot with more.
No, we're just doing the other one.
Okay.
Oh.
When there's not a lot, like here this was fairly spread out, okay? But when it's only like, say, if that data was only in the 20s and the 30s, just having 2 rows wouldn't be that useful. So we might split the 20s up into 2 rows. So the reason I only wrote 1, 0 is like the first of each row is if the 1's digit is between 0 and 4. Okay? So if I wrote that other 0, it would be blank because we don't have, and then this would be the 5. And then we would have 1, 3, 3, and then 6, 7, 7, 7, 7. So sometimes this is called a split stem plot, and the idea is that so then we could see that there's a gap here.
Okay, so you,
Now, when you have a gap, you leave it blank. You don't just ignore it. You're there to because it's worth noting seeing that gap.
should we write that down?
You don't need to. I just want you to be aware that if you ever see that, that's what's happening. Okay? Feel good so far?
Yes, so.
Dot plot. A dot plot looks like a bunch of dots. It's done over a number line. So my smallest number is going to be 5. My largest number is going to be 45. I'm going to split the difference in the middle with a 25. I would recommend, because it has to be done against an actual scale, what I like to do is start with the highest and the lowest, and then find the midpoint of those, and then do my scale that way, because I feel like otherwise you end up doing that thing where you're putting in your tick marks, and all of a sudden you're trying to fit those last few into a smaller space. You guys know what I'm talking about there, right? If you start with your highest and your lowest, then put your midpoint, and then do the midpoint of that, that usually works pretty well. Everybody good? Okay, so I'm going to make it for the 5. I'm going to put a dot here. For the 11, let's see, this would be 10, 20, 30, 40. So the 11 would be right about here. The 13, 16, 17, 18, 19, 17, 17, 17, 17.
Wait, why do we have number of? Oh wait, never mind.
Because that's the context.
Those are just random numbers.
This is so much fun.
It gets old really fast, I hate to tell you. Depending on the size of the data set, they start getting very frustrating to make. And notice that same gap that we had here, that we couldn't see here, is definitely visible here.
My dots are a bit tiny.
Do you guys get what I'm saying there? Okay? And those gaps matter in terms of some of the things that we might be looking for as weird trends. Okay? It is not normally distributed.
Womp womp.
It could be normally distributed, but not like it in a normal distribution graph. The y-axis stands for the frequency, and the x-axis stands for the variable. We kind of have two variables going on here. Yeah. Okay. So this is called a time series plot. Does anybody want to guess why it's called a time series plot? The x-axis is some version of time, and you're looking for like how things go up and down over time. Yeah. And then there's like interesting things as to why. So looking at these. Does anybody want to look at what does this graph communicate about history in general?
Cars.
Car violations,
When
traffic
we have-
violations.
when-
Can you explain what's happening in this graph?
Oh, the amount of traffic violations went up and had a peak.
It was the highest in the like 1970s and 80s, right? And can anybody think of a possible explanation why things were lower here and higher here?
People got better.
Turn signals.
Turn signals and
Cruise
adding
control.
brake lights and stuff like that actually makes a lot of sense here. Why was it so low here?
Because
Little
they're-
little cars. Like little
Not nearly as many people were on the road.
So I was right about brake lights and signals.
I would put it into a broader perspective of the 80s and the 90s. Cars advanced quite a bit. You added cruise control. You added
emergency brake.
more drunk driving laws. Right? So there were things that happened over the time of history that explains what's happening in this graph. Much like right now, what is the new innovation in cars right now?
Full self-driving.
The self-driving, have you guys ever, do any of you have one of the cars that stops if the car in front of you starts to stop? It's really trippy to drive one.
It's scary.
Yeah, that.
It's like, but those innovations are causing a decrease in traffic accidents as well. So, but are you guys with me that this time series plot says there's a trend and there's a story behind that trend, right? And so the big idea of a lot of the time series plots is what's happening over time to help us make conclusions about or predictions for the future. Inferential statistics, these are descriptive, but when we use them to make predictions to the future, that would be inferential. Yeah, just to kind of go back to those vocabulary words. The number of traffic violations is a discrete quantitative variable because you can't have 3.2 traffic violations.
Yeah.
A warning.
On average, though.
No, we have locust warnings. Not analysis.
Oh, box plot.
Box plot.
Done that.
I know we've done box plots
Yeah.
before.
Box and whisker.
Also, nobody actually says stem and leaf plot. They just say stem plot. But that's like, it's like one of those, yeah.
It's a meow plot.
It's a meow plot, according to Savina, yes. Okay, this is a box plot. This is a modified box plot. I like the modified ones best. Most of the stuff I'm going to have you do is a modified one. Okay? Yes, I know that last semester, most of you guys, we did box plots. So I'm not going to spend a ton of time on them yet. Next week, you are going to be asked to find all of those values, the Q1, the Q3, all those things by hand. We're going to go over in detail how you find those things. Yeah.
It's just the max is an outlier, so it's not.
Yeah, so in a modified box plot, the whiskers, for lack of a better word, connect to the highest point that is not an outlier, and then outliers are freestanding points. So a modified box plot and a box plot would match for a data set that doesn't have any outliers. Everybody good?
Yes.
Yeah.
Okay.
Wow, this one might be the easiest.
The biggest shift, though, is this is not a histogram.
It's different.
Because this is categorical or qualitative data. And is there any reason we typically do the most frequent on the left and bring it down as it goes? Okay, so we start with the most frequent and so on and so forth for a Pareto chart. I actually don't know how to pronounce that. It might be Pareto. And then I'm assuming you guys understand pie charts.
Yes.
No.
Are we gonna have to like make those?
I don't really intend to have protractors available to you.
Darn.
That's good.
I would, because that's what you would need, right? Is a protractor, because you'd have to draw those center angles. That being said, I could see, I can't remember if it's in this Excel lab, but like using technology to create one of these. Yeah. And when you guys get that first Excel lab, as soon as I can give it to you, I will. When you guys get that, you're going to be like, oh, this isn't that bad. It's really just following directions, and then you'll have those directions in case I ask you to use some more things in the next. Okay. How are we feeling on these different, are you with me that I gave you lots and lots of different kinds of graphs? Do I have any more?
Are these like most, if not all of them, we're gonna like need this?
Yes.
That's
I suck at following
Okay, so when you get a histogram, if I give you a histogram, all right, one of the things that becomes important is we start thinking about what does that histogram tell us? And the shape of the histogram is a huge component of it. Okay, so I want you to be familiar with the different shapes. This one is uniform, in that it doesn't matter what the weights are. They're all, like, the heights of the different weights are evenly spread out. What do you guys think this one's going to be?
mountain.
Not uniform.
Not uniform.
Down.
Okay, now you're allowed to say what you wanted to say before.
Normally distributed.
This one's approximately normal.
True, but
Almost normal.
but you.
Okay, so what's keeping this from being normal?
The
Left side.
yeah.
The left side is what keeps it from being normal?
Right side. Both.
Okay, so there's two ways we could describe this. It's what we call, it's skewed, okay? And when you're describing a skewed histogram, you're describing where the weird tail is, right? Like, if this weren't here, this would look maybe closer to normal, yes?
Maybe.
So the right tail is what makes this tailed off, okay? So we might call that skewed to the right, or positively skewed. Does anybody want to guess what this one is? Skewed left
Negatively skewed.
or negatively skewed? We can be more specific than gapped.
Split.
We call it bimodal.
I was gonna say.
Right. That one was something.
We could call all three of these unimodal, that they have one kind of peak of where the values are, or the observations are, where there's definitely two peaks of where the observations are here. Does this make sense?
Yes.
Unimodal. But like, when it's unimodal, we typically want you to go into more detail, right?
Done, man.
We're done.
Let's go. Can I look at